Welcome everybody to example 8 on page 116 of the workbook. And this is another example of using the substitution rule to evaluate an integral. Now in this problem, I want to change things up a little bit and illustrate that making a u substitution, there's a little bit of trial and error involved in this process. Every problem that we've done up to this point, we kind of chose a u and everything worked out nicely and we got an answer and that was it. But a lot of times when you're doing this on your own, you might make a choice of u that doesn't work, okay, which is okay. That's a natural part of the process. And so I'd like to just illustrate kind of what that looks like, how you might recognize when a particular choice of u doesn't work and what we might do about it. Okay, so that said, let's suppose that as our first attempt at this problem, we make the choice u equals sine of x. Okay, in and of itself, nothing wrong with that choice. We see that there's a sine of x in our problem. Okay, so if we make that choice, our next step would be to choose a du, or to calculate du, the derivative. Derivative of sine of x is cosine of x, so du is going to be cosine of x dx. Okay, we'd go ahead and solve that for dx. Okay, and again, we're interested in those two calculations that we did. We're going to substitute back into our integral. Okay, so if we make those two substitutions, the sine of x that's up here in the numerator, that's what we called u. Okay, then we've got a cosine squared of x in the denominator, and the dx, we can see from our work, is equal to du over cosine of x. Okay, and then we would simplify this. Notice that we've got a cosine of x squared and another cosine of x, and so we could rewrite this as u in the top. We've got a cosine cubed of x in the bottom. That's cosine squared of x times cosine of x, and then a du. Okay, but what do we do now? Notice that we've got a cosine cubed of x in the bottom that's still there. It didn't cancel, and so our integral has two variables in it. For this method to work, we need to get an integral that just has one variable in it, just u, and so we're stuck at this point. We can't go any farther. Okay, so that's a sign then that this u that we chose just didn't work, and that's okay. This will happen when you're doing this method, and if it does happen, you just back up and try a different u. All right, so let's cross this out. First attempt didn't work for us, and we'll try again. Okay, so what else could we choose for a u? All right, well, notice in the denominator that we've got a cosine squared of x. We could rewrite that as cosine of x squared. That might suggest that a reasonable choice of the u for u would be the part on the inside, cosine of x. Let's try that. Okay, if we make that choice for u, then the derivative of u is going to be negative sine of x. So du is negative sine of x dx. Go ahead and solve that for dx, and we're going to get du over negative sine of x equals dx. Let's see what happens when we substitute that into our integral. Okay, so this time, let's see, we've got a sine of x in the top. Okay, and then u was equal to cosine of x, which means that this denominator, cosine squared of x, is going to turn into u squared. And then we can see from our calculations above that dx is du over negative sine of x. Okay, does that look better than what we had before? Well, notice the signs are good here because sine of x cancels. Okay, so what's left over in our integral then here? Well, the sine of x in the top canceled, so we've got a 1 over u squared, and then we've got a du over negative 1. The negative 1 survives. Okay, and that negative 1 is a constant, so we could pull it outside of the integral. Because it's a negative 1, we can really put it in the numerator or the denominator, so I'm just going to pull it out as a negative 1. And then we might notice that 1 over u squared, we can rewrite that as u to the negative 2. I'm going to rewrite it that way because it might make it easier to actually do the integral that we're looking at here. Okay, so signs are good. We came down to an integral that just has u's in it. Okay, and so if we can find an antiderivative for u to the negative 2, okay, we can continue with this problem. All right, so sneak a peek at our table of integrals here, and do you see a formula that might help us there? Okay, remember that u to the negative 2 was the function that we want to integrate. Notice that that matches the first formula here. Okay, we're going to be using the power rule, which tells us to raise the power by 1 and divide by the new power. Okay, so if we do that, we've got a minus sign out in front of the integral. Okay, if we apply the power rule to u to the negative 2, we'll raise that negative 2 up by 1. Negative 2 plus 1 is negative 1, and divide by the new power. Okay, and then it's an indefinite integral, so there's a plus c at the end. Okay, and notice that the two minus signs here and here cancel, so we actually get a positive out of this. U to the negative 1 plus c, and the very last step is to just go ahead and substitute the u back in. Okay, our u was sitting up here, it's cosine of x. So we're going to get cosine of x to the negative 1 plus c, and there's our answer. Okay, so this just illustrates that sometimes when you're using a u substitution, you might make a choice of u that doesn't work, and that's okay. You just back up and try something different.